Okay, so we're just going to do a quick little, uh, I don't know, you call it a test, a rundown, a whatever. We got a circuit board here, and it will take power by the battery terminals coming in and work fine. But whenever the power supply terminals here that would normally charge your battery and run the board, it doesn't work. So I don't know how well you can see, but I'm going to try and zoom in. Okay, Kevin, zoom in here. And you'll probably figure out what's wrong with it. Um, but that may not be the only thing that's wrong with it. In this particular case, these are pop riveted in place. And so when I replace it, I'm going to actually just put a screw in there to bolt the other one to the heat sink. And we'll see how that goes. We'll get in there and yeah, it's heating up. So I've got my desoldering gun heating up. We'll get in there and replace it. And while it's out, I'll probably go ahead and just test certain little components here around the board. Looks like we have our capacitor. The diode, I don't think has got any issues, but I'll test the capacitor and the resistors. Test those against short to make sure nothing's shorted, and chances are everything's going to be fine. The rest of these capacitors here, the tops are flat, so they're most likely in really good shape. They don't show any signs of any issues. Again, I don't think there's any problems because the battery will run the board and it'll function perfectly, but it only functions on battery because the voltage regulator. So what we have, what we have is two voltage regulators here. We have a set voltage regulator here, and it is already set at a specific output. And then we have an adjustable voltage regulator here, which not sure if you can see, but again, we'll try and zoom in. Let me see if I can get closer to under the camera maybe. Right here, you'll see a little pot. It's adjustable, and you will adjust the voltage regulator's output using that. So let's get this desoldered. My soldering gun is up to heat. Just kind of lay this over on its side. See if we can get this stuff desoldered. I should have a bigger tip on here. Cheap tweezers here. Okay. You see where it blew out the bottom? It doesn't seem to have damaged the board, just left a little dark spot on it. Here's part of the chip. Here's the other part of it. Give you an idea to see a little bit of what's inside one of these things. And that's basically how it would normally go. Let me see what my work phone is doing. Interviews in the morning. Okay, so this is the part that we're having a problem with. This is a JM49AB. It is a LM2576 HVT adjustable P plus. So, and that gives you an idea of what the leads are. So now we're going to kind of get into our next issue. That's how inconvenient they are. You got to bend them. To whatever configuration the people who used them bent them to use them. So I need some tweezers. So let you know what, the gubba dime is batting 1,000. So let's. Oh my goodness! Come on, really? Imagine that. So the gubba dime, it's almost the perfect width. 1, 2, and 3. So we will do this. And see, that's right there at the full depth. So that is perfect. 1. And 3. And then I got to figure out how to get 2. And 3. Okay, so now we've got those 3 bent forward. Now, I don't know if you can notice, but there is like a little wider section right about here. Pretty much exactly where I bent them. And what that is, it's a stop. So these leads can penetrate the board up to this point, and then they're going to stop because they have a natural stop built into the chip. And so you can see that the way the configuration is you've got these two, the first pin's bent down, the next one's straight like this is. Next one's bent down, the next one's straight like this one is, and then the next one's bent down like this one over here. And so now what I've got to do is I've got to take these and I've got to bend them back up at the right spot to match the board. And I mean, there's probably exact specifications for this kind of stuff, but we're just eyeballing it. So now we're going to bend them to try to get them, pretty well lined up so they'll match up to the holes. And so there, we've pretty much got it bent to match this. Now we're going to have to trim them once we solder them in, but that'll be in just a moment. So here you can see we've kind of got it matching these. Now these right here were kind of bent like forward in, so I may have to do a little bit of adjustment on them, but that's fine. That's not that big of a deal. I think that is pretty doggone close to the original bends on these chips. And if I'm not mistaken, I think they have a jig to be able to bend component leads specific to whatever may or may not be needed. Now we'll go ahead and turn that solder sucker off. I don't see any signs of any kind of damage anywhere. So I think those other components are good. I believe that this variable voltage regulator blew up before it caused any damage to anything else. And the place that it is this installed is very prone to what I call brownouts. I said something to an electrician one time about brownouts, and he said, "What are you talking about?" I said, "Brownouts, voltage drops." He said, "Man, they ain't called that. They ain't no such thing. You have blackouts or you have electricity." I said, "Nope, they have brownouts." And I don't think he liked it when I proved him wrong, but he was wrong. They have brownouts. Good, bad, or ugly. They got some. I don't have a short smaller. Let's make sure this will actually go through here. Yes, it will. So I think we're all good there. Now my preference would actually be a smaller nut or whatever, but I do know the box that this is going in. This extension sticking out over here is not going to be a deal. So we're going to get this. I'll try to get this placed in there. And this right here is, it is basically just to kind of show you how to go about replacing components like this. So I got the longer leads in the hole. Kind of good. Let's hold on. Let me just do a quick adjustment. It'll just make it that much faster. Move that in a little bit, and that in a little bit. So maybe that little bit was too much. Okay, so now we've got it dropped down into place, and you can see our legs are poking out the bottom just a little bit further. And so at this point, what I always do is I'll bend them legs to kind of hold the component into place, because I need to get up here and put this nut in it. And I think I'm just gonna, I didn't check to see if this would actually fit on top, which that probably wouldn't tell me anything. So I decided to go ahead and do it this way, so that I know there's nothing on this side of the box, so it's not going to make a difference. It's not going to interfere with anything with installing it in there, but just to be on the safe side. So that's snugged up. It doesn't have to be super tight. This is just a added heat sink going on to this voltage regulator to help dissipate some of the heat on the voltage regulator, because it's going to heat up. And there was no dielectric on here, and there's really not. This isn't a prepared finish. This is like anodized or painted or something, and that is not something that you would literally put dielectric on to get a bonded heatsink. So I'm not going to bother with putting more heatsink on there. At this point, I can straighten these leads up because I have it screwed into place. And where I can't, I just solder them in place and then take and chop these off after the fact. But they're not going to move because it's screwed in. So now let me get my desolder out the way, get my meter out the way, and we're going to hook up to HSO2A, and we're going to solder this component. So I was not in any way concerned about any kind of heat taking it out. I mean, if you think you're taking a good component out, don't disconnect it from the heatsink first. Desolder it so you don't risk overheating it. But of course, that one had already previously been overheated, so I wasn't worried about it because I'm replacing it anyway. So let's get the, like I said, the HSO2A out. We're going to hook this into my normal benchtop, not my lab benchtop power supply, just my regular old GAN 260 watt. Really, I think it's called a charger. I did a video on it, so you can find a video. If you go back through my older videos within the last year, I think it is still within that time frame. But if you go back into the older videos, you'll find a video on it. I think I want to use some solder paste on this. I don't really have a tip to stick up in there, but that's okay. I don't even know if I cut this yet. Yeah. Way more than I actually need. That is what you call overkilling the solder paste. But that's old Bacaba. Get my little sad solder. This actually come in a kit to build a piece of test equipment with. That I haven't finished the project, but now that I'm doing videos, I'll wait until I actually can video the remainder of that project. Oh, let's turn it on. And we're already set 365, which is probably a little hot, but okay, so it looks like we got some good solder connect joints on it. Turn that off and let it cool. And that's one of the good things about these iron is I'm not worried about it cooling down. I'm just going to turn it off, put the cap on it. I can set it anywhere. This aluminum cap's not going to heat up enough to cause anything to get hot, even though it's 365 Celsius. And I don't care if it completely cools down before I use it again, because it's going to heat up so fast. I'm sorry, my brain's goobered up. 91% isopropyl alcohol. And let's see, I got some Q-tips up here. Okay. Now, let me grab my top secret component lead cutter. As I knock my desoldering gun on the floor. Now, like I said, this is top secret. And it's made by a Quibeo body care. Sure. And we're going to take these component leads off. Now, I'll explain why this can be a very bad thing in just a second. But I got to put all my concentration into this. So, reason being is these leads here popping up and landing somewhere on the circuit board. But this is the bottom side of the circuit board. It's not really any place to wedge, so chances of that being an issue are very, very slim to none. But it is something to be aware of whenever you are replacing components on a circuit board. The pictures, because I take pictures of everything before I take it down, just to be on the safe side, so that I can definitely put it back together exactly the way it was before. And in this case right here, there was a couple of wires down here, which I did take a picture of those wires, but all of the terminals, make sure it's screwed down, and I just unscrew the ones that had the wire on it, and I left them unscrewed. So I offhand, even if I can't find the picture, I know which terminals my wires were laid down on already. And so that kind of saves a lot of time if I have any potential issues. So anyway, that's all I got. I just wanted to basically show, bending the leads, setting up a component, and sticking it in the board, and how I do it. And in addition, you tell me where I did something wrong and could have done something better. I'm always open to learn better, faster, quicker, more reliable ways of doing things. So I appreciate you. I thank you. I enjoy spending time with you, and I will see you next time. Your time is very important to me, and I thank you for spending it here with me. Thanks, and God bless.